Welcome to our physical science class, children. In this session, our discussion topics are net force and effects of net force and free body diagram. In generally, many forces can act simultaneously on an object. For example, when we place a book on a table, we already know about how many forces acting on this book. One is gravitational force acts vertically downward direction, that is indicated with Fg. Other one is normal force that acts vertically upward direction, that is indicated with Fn. Do you observe any change in the state of rest of the book? There is no change in the state of the book because these two forces acting on the book are equal and opposite in direction. So, there is no change in the state of the book. We can say that the net force on the book is 0. Here, net force is indicated with F net. Here, net force is equal to Fn minus Fg. So, these are normal force and gravitational force. These are equal in magnitude but opposite in direction. So, the net force acting on the book is 0 newtons. Newton is the SI unit of force. Here, minus sign indicate the forces are acting in opposite direction. See children here, in first figure, a boy pushing a table using F1 force on the table. In second figure, two boys are pushing same table using F1 and F2 forces. In which case table moves easily? In the second case, table moves easily because the force F1 applied by one boy added to the force F2 exerted another boy results in the both forces being applied on the table in the same direction. The total force applied by both boys made it easy to move the table. All forces have both magnitude and direction. While adding forces, the direction of forces have to be taken in account. When forces act on a body along straight line and they are in the same direction, the net force is taken as the sum of the all forces acting on the body. Here, F1 and F2 are acting on the table same direction. So, the net force is equal to F1 plus F2. So see children here, second case, the total force or net force is equal to F1 plus F2. Here, in the third case, two boys pushing a table in opposite direction. What happened? Does the table move? When two boys push the table from opposite side, the table does not move. If both forces are applied by the boys are equal in magnitude, so the table does not move. So there is no change in the state of the table because in this case the net force acting on the table is 0. Children, imagine one of the force F1 is applied by the one boy is greater than another force F2 applied by the another boy. What will happen? In which direction table moves? F1 force is greater than F2. So the table moves in the direction of F1 force. When we added forces, sign convention must be used. The force F1 directed towards right could be taken as positive and the force F2 acting towards left could be taken as negative. The forces F1 and F2 act on the table in opposite direction. If F1 is greater than F2, the net force is equal to F1 plus of minus F2. Here, net force acting on the table F1 minus F2. The forces on a body in a straight line or in opposite direction. The net force is equal to difference between the two forces. If the object at rest moves in the direction of the net force acting on the body. So here net force means the algebraic sum of all the forces acting on a body is known as net force and is denoted by F net. Force has magnitude as well as direction. We represent the direction of force magnitude using arrow. The unit of force in SI system is Newton, that is denoted by capital N. Now we are going to learn about effects of stretched rubber band on fingers. Take a rubber band, stretch it using your fingers. When you stretch the rubber band, it exerts force on your fingers. We add one more similar rubber band around your fingers and stretch both together to the same length. Now you feel the combination of two bands exert a large force than one rubber band. Now we increase the number of rubber bands around your fingers. What happened? The force exerted by rubber band also increases. Now we consider the force exerted by one rubber band is F units, and the force exerted by the second rubber band is also F unit. Here the force exerted by the two rubber bands is equal to net force is equal to F plus F, that is equal to 2F newtons. Now we take the three rubber bands, the net force of the three rubber bands, that is equal to F plus F plus F, that is equal to 3F newtons. Now we increase the number of rubber bands. We feel the exerted total net force exerted by the rubber bands also increase. Now we are going to learn about how to calculate the net force from free body diagrams. Free body diagram means the diagram showing all the forces acting on an object at a particular instant is called free body diagram. It is denoted as FBD. Here, a car moving with a non-uniform speed along a road. Now we draw all the relevant forces acting on a body. Now it is called as a free body diagram, that is FBD. So here the force acting on the car, the force applied by the engine is capital F. So here the frictional force applied by the road is small f. Normal forces are N1 and N2 acting vertically upward direction. Here N1 and N2 are the normal forces acting on the car upward direction. Here gravitational force acting vertically downward direction, that is W. Now we use a coordinate system with x-axis and y-axis. Sign convention is to be taken along x and y-axis direction. Along x-axis we take the positive values on right side and we take the negative values on the left side. Along y-axis we take the positive values upward and we take the negative values downward. Add these forces algebraically with sign conventions along the x and y axis separately. Then the values give the net force along the x and y axis direction. So here net force along the x axis or direction, net force along the x axis, that is the frictional force acting, and applied engine force, that is the capital F. These are acting along the x-axis direction but opposite. So the net force acting along the x-axis, that is equal to frictional force minus engine applied force. So here small f minus capital F. Here net force along the y-axis or direction. Here net force along the y-axis, that is N1 plus N2 minus W. Here N1 N2 the normal forces acting on the upward direction along the y-axis, these are positive, and gravitational forces acting on the downward direction along the y-axis. Here we take the negative sign. So this is the free body diagram of a car which is in non-uniform motion.